Good morning, my dear friends. I am a chemistry teacher, Bethlahem Higher Secondary School, Karungal. Okay, how are you? Did you learn the previous portion? Okay, yes. Okay, today our selected portion is P block element 1. This is the second lesson. Our learning objectives to describe the general terms in the properties of P block element. And one more objective, to explain the anomalous property of the first element of P block group. These are our two objectives. First of all, we should be learned what is the P block element. We know that in the modern periodic table, the elements are arranged as per the atomic number. We have four types of block element. That is one S block element, P block element, D block element, and F block element. The S block element already we learned in the small class. In our this year portion, we have P block element. We have 7 periods and 18 groups. Well, this P block element, what is P block element? The element in which the last electron enters in P orbital. That is group number 30, group number 32, group number 30 to 18 group is called P block element. The 13th group is called as the boron family. The 14th group is called silicon family. The 15th group is called nitrogen family. The 16th group is called oxygen family. The 17th group is called halogen family. The 18th group is called inert gas, noble gas or rare gas. Okay? The 13th group is called the boron family. The 14th group carbon silicon family. The 15th group nitrogen phosphorus family. The 16th group oxygen family. The 17th group halogen, that is fluorine, chlorine, bromine, iodine family. The 18th group inert gas, noble gas. This block contains metal, non-metal and metalloids. This block contains metal, non-metals and metalloids. The P block element and its compound is very important in our day-to-day life. It has many advantages, many significance. For example, the molecular oxygen is very essential in our life. And also the aluminium play very important roles in the aircraft. And the germanium and silicon is very used as a semiconductor for the electronic device. So the P block is very important lesson you should learn around. I told you that our learning objectives. What is our learning objectives? To describe the general trends in the properties of P block element. Okay. The first one is electronic configuration. First one is electronic. The electronic configuration of P block element having the general formula NS2 NP126. This is the common electronic configuration of P block element. Each group having a similar electronic configuration, but it differs the value N. What is the meaning of N? N means principal quantum number. Quantum number having 4 types. Principal quantum number, azimuthal quantum number, magnetic quantum number, spin quantum number. Here, the n refers the value means principal quantum number. It denotes the subshell. That is called n. Here, the 17th group, that means I told you the 13th to 18th group. The 17th group is called as a completely filled subshell. The 18th group is called as a completely filled subshell. It is chemically inert, and it is this group is otherwise called noble case. Okay. We can how to write the electronic configuration of this group. How you write the electronic configuration of this group. First of all, the group name, that is 13th group, 14th group, 15th group, 16th group, 17th group and 18th group. Here the first one group, the atomic number is 13. Did you know how to write the electronic configuration of atomic number 13? 13th group. The first one is called boron. The atomic number of boron is 5. How can you write the electronic configuration of boron? That is, first to write 1s, 2s, 2p, 3s, 3p, 3d, 4s, 4p, 4d, 4f, 5s, 5p, 5d, 5f, 6s, 6p, 6d, 6f. Okay? There are 4 subshell: S subshell, P subshell, D subshell and S subshell. Yes, we can be accommodate 2 electrons. Each P subshell we can be accommodate 6 electrons. Each D subshell we can be accommodate 10 electrons. And each F subshell we can be accommodate 14 electrons. This is the increasing order. We start with 1s. Already I told you each S can be filled 2 electrons. As per here, boron have the atomic number 5. First start with 1s. That is 1s we can be accommodate 2 electrons. 1s2. Second one, finish the second one. 2s2. The next one is start with here. 2p1. So the atomic number is 5. 2 plus 2, 4. 4 plus 1, 5. This is the electronic configuration of boron. The next one, carbon. The atomic number of carbon is 6. How will you write the electronic configuration? Same, 1s2, 2s2, then 2p2. 1s2, 2s2, 2p2. Next about the atomic number is, next one is 15th group is nitrogen. The atomic number is 7. How will you write? 1s2, 2s2, 2p3. The next one is oxygen. What's the atomic number? 8. What's the electronic configuration? 1s2, 2s2, 2p, etc. etc. So, they give the general electronic configuration for group number 13 is ns2, np1. That is 2s2, 2p1. For the general configuration is ns2, np1. The second category, that is a 14th group, ns2, np2. That is 2s2, 2p2 for carbon. Next one, NH2 NB3, that is for nitrogen. 2S2 2P3. Next one, NH2 NB4, NH2 NB4, etc., etc., etc. You should be take written practice. And also, it shows the highest oxidation state. It shows the highest oxidation state. For the 13th group, the oxidation state is +3. That is 2 plus 1 plus 3. 2 plus 1, 3. Next one, 14th group, that is 4. 2 plus 2 plus 4. Next one, 15th group, 2 plus 3, 5. 5. Chalcogen family, 2 plus 4, 6 plus 6. Then 17th group, 2 plus 5 plus 7. 18th group, 2 plus 6, 18 plus 8. Like that. It's the oxidation state. And also having the theoretical, as per the theoretical explanation, if the other absurd oxidation state is also having this, refer the textbook and learn this one. It's a very, very important for the one value question. Okay. Please take down this electronic configuration. How you write the electronic configuration of this P block element. Shall I rub the board? Okay. Okay, the first one is electronic configuration. It's over. Electronic configuration. Second one is metallic character. Metallic character. What is about the metallic character? The tendency of an element to lose an electron to form cation. An element lose an electron to form a cation. That is called what? Metallic character. This is based on only ionization energy. If ionization energy is increases, what happens? The metallic character is decreases. That's the concept. Ionization energy is increases, metallic character decreases. The next heading is metallic nature. The tendency of an element lose an electron to form cation. The tendency of an element lose an electron to form a cation. This is based on ionization energy. This is based on ionization energy. The ionization energy is decreases, metallic character is increases. Ionization energy is decreases, metallic character is decreases. Classification. Here, metals are occupied on the left corner in the periodic table, and the non-metals are occupied on the right corner of the periodic table. So metalloids are all occupied on the middle of this P block element. That is the 13th group. The first one is boron, is a metalloid. The remaining all elements are metals. The 14th group, the first element carbon is a non-metal. Silicon and germanium is a metalloid, and tin and lead are the metal. The 15th group, nitrogen, phosphorus are the non-metal. Arsenic and antimony, these are metalloid. Bismuth is a metal. The 16th group, oxygen, sulfur, selenium is the non-metal. Tellurium is a metalloid and polonium is a metal. The 17th group is a fully non-metal, and 18th group is also a non-metal. This is about the metallic nature in the periodic table. The next topic is ionization energy. Ionization energy. In the lower section, in the lower class, we maybe learn about the ionization energy. the amount of energy required to remove most loosely bound electron. The amount of energy required to remove most loosely bound electron. Here the ionization energy decreases. Because the reason is, from top to bottom the atomic size is decreases, the number of atomic size is increases, the number of shells also increases. So the distance between the center of the nucleus and the outermost shell is also is increases. So we can be easily remove one electron from the valence shell. It is easily removed. So ionization energy decreases. Next topic is electronegativity. As we move the 13th group, the electronegativity first decreases from boron to aluminum. First decreases from the 13th group, boron to aluminum is decreases. In the case of gallium, it is marginally increases. That is in the 13th group. The same and also about the 14th group is also same like that. First one is decreases, carbon to silicon decreases, and also germanium is almost increases. In the case of 15th group, 16th group, 17th group, and 18th group is almost decreases. This is about the electronegativity. The next objectives. This is the first objectives to describe the general trends in the properties of p block element. 4 topics. One is electronic configuration, metallic nature, ionization energy, and electronegativity. The second objectives. Second objectives, anomalous properties of the first element. To learn about the anomalous properties of the first element. This is the learning objectives 2. The first one, the first member of the group is differ from the other elements of the corresponding group. The following factors, they have 3 following factors. Number 1, the first one is small size of the first member. First one is small size of the first member. Second one, they have high ionization energy and electronegativity. They have high ionization energy, and electronegativity. Third one, absence of vacant d subshell. Absence of vacant in their valency shell. Absence of d subshell in their valency shell. These are the 3 points. Okay. The first member of the group, boron is a metalloid. As I told you, boron is a metalloid. Other metals are the reactive metal. All the metals are the reactive metal. There is some relationship between a diagonal relationship between boron and also silicon. This boron and silicon oxides are acidic in nature. Which nature? The boron oxides of boron and oxides of silicon are acidic in nature. Both boron and silicon forms covalent hydride. Both silicons and borons form covalent hydride. This was about the 13th group. Next about the group number 14. About the group number 14, The first member, carbon, is a non-metal. One of the great capacity for carbon, it can form a bond. Carbon can bond with the carbon. That process is called catenation. It's a non-metal. For example, carbon can form with multiple bond. Carbon-carbon bond. For example, how can you draw this one? The atomic number of carbon is 4. Atomic number of carbon is 6. The outermost shell is 4. That is, first shell have 2 electrons, second shell 4. There can be dot diagram for carbon. Outermost shell have 4 electrons. Then this is another carbon. There also have 4 electrons. That is forming the 2 bond. It's called carbon double bond. Like that, it can form a multiple bond. Carbon, so multiple bond. Carbon have a great capacity to form a chain of bond with other element. That is called catenation. Next group is group number 15. About the group number 15, group number 16. The group number 15, the first member is a diatomic nitrogen gas. Group number 16 is also like that. It is a diatomic oxygen gas. Then about the group number 17, it is a halogen. Halogen group number 17. Fluorine, chlorine, bromine. This is the halogen. This is the first member of this group is fluorine. Fluorine is the most reactive element in this group. Fluorine is the most reactive element. Fluorine is the strongest oxidizing agent. It is the most reactive element. It is the most electronegative element. Strongest oxidizing agent, and it have the negative, that is a -1 oxidation state. This is about this anomalous properties of the first element. The next one is the next question is allotropism in P block element. Allotropism. Allotropism in P block element. What's the meaning of allotropism? The molecule having different form, having one more form. For example, carbon exists. Already we learned about the carbon. Carbon exists two forms. Graphite and diamond. Like that, more than one form. That is called allotropism. This allo means another, and tropy means change. That is one form to other form, means change. Some of the forms maybe. Some common allotropes of P block element. First one, boron. Most common allotropes for boron. It's a very important for the 2-mark question. Very important. First one, boron, amorphous boron, alpha rhombohedral boron, beta rhombohedral boron, gamma orthorhombic boron, alpha tetragonal boron, beta tetragonal boron. Next about the carbon, diamond, graphite, graphene, fluorines, carbon nanotubes. Next one is silicon, amorphous silicon, crystalline silicon. Next about the germanium, alpha germanium, beta germanium. Next, tin, grey tin, white tin, rhombic tin, sigma tin. Phosphorus is very, very important for the phosphorus. White phosphorus, red phosphorus, scarlet phosphorus and violet phosphorus. Arsenic, yellow arsenic, grey arsenic, black arsenic. Antimony, blue, white, antimony, yellow and black. Oxygen, dioxygen, ozone. Sulfur, rhombus sulfur, monoclinic sulfur. Selenium, red selenium, grey selenium, black selenium, monoclinic selenium. Tellurium, amorphous and crystalline form. These are the most common allotropics. These are all important 2-mark questions. You should learn, all of you. The next learning objectives to learn about boron and its compound. To learn about boron and its compound. The important words of boron is borax and kerinite. The two important words, borax and kerinite. The formula is Na2, formula Na2, B4O5, OH 4 times 8 molecules of water. This is the formula for borax and kerinite. Na2 B4 O5 OH 4 times 2 molecules of water. This is the chief ore of boron. One is borax. What is the formula? Tell me. Na2 B4 O5 OH 4 times 8H2O. Next one, Na2 kerinite, Na2 B4 O5 OH 4 times 2H2O. The aluminum is the most abundant metal. All of you know about that aluminum. Aluminum is the most abundant metal and it occurs at oxide and also found in aluminum silicate rocks. It is extracted from bauxite ore. All of you know about the bauxite ore. What is the formula for bauxite ore? Al2O3, Al2O3, 2H2O. This is the bauxite ore. Having some physical properties. Having physical properties of group 13 element. Properties. And that is the first one, physical state. Boron is a solid. Aluminum is also solid. Gallium solid. Indium solid. And thallium also solid. Then atomic number already learned. The atomic number of boron is 5. Aluminum is 13. Gallium is 31. Indium is 49. Thallium is 81. Isotope, boron 11. Aluminum 27. Gallium 69, indium 115, gallium 205. Also the experimental value, that is the atomic mass weight, 10.81, 26.98, 69.72 for gallium and indium 114.81 and gallium 204.78. The electronic configuration already learned. Electronic configuration. Here having one short form of electronic configuration. This is a very, very important. How to write the short form of short form. That is, for example, boron boron, the atomic number is 5. As per this rule, 1s, 1s, 2s, 2p, 3s, 3p, 3d, 4s, 4p, 4d, 4f, 5s, 5p, 5d, 5f, 6s, 6p, 6d, 6s, 7s, etc. Okay, first one boron, start with 1s. 1s we can be, already told you, the s subshell we can accommodate 2 electron, p subshell 6 electron, d subshell 10 electron, f subshell 14 electrons. Here short form, how will you write the short form? First you write the full electronic configuration. First 1s2, second one, the red line is over, second one, 2s2, next one, 2p1. Here, they have a short method for writing the electronic configuration by using the inert gas, that is we are using the noble gas, helium, neon, argon, krypton, xenon, whatever it can be used. First one I am taking helium. Helium, the atomic number of helium is 2. We can be write helium for 2. 1s2. Am I right? 1s2. Okay. For this, we can be used this 1s2. We can be used helium. Okay. Then this 1s we can be used helium. That is Ec is equal to helium. Remaining you should be right. What's the remaining? 2s2, 2s2, 2p1. This is a short form. And for the second one is aluminium. What is the atomic number of aluminium? The atomic number of aluminium is 30. How will you write the electronic configuration? Ec is equal to 1s2, 2s2, 2p6, 1s2, 2s2, 2p6, 3s2, 3s2, next one, 3p1. Now count this. 2 plus 2, 4, 4 plus 2, 4 plus 6, 10, 10 plus 2, 12, 12 plus 1, 13, over. For here, we are using neon. What's the reason is, the atomic number of neon is 10. For 10, we can be write the electronic configuration 1s2, 2s2, 2p6. So we are using neon here. So Ec is equal to, for aluminium neon, close the bracket, next 3s2, remaining right, 3s2, 3p1. This is the short form. Okay. Next one we can take one more practice, that is called gallium. Gallium, the atomic number is 31. Atomic number of gallium. Gallium is equal to gallium, Ga is equal to 31. Electronic configuration start with 1s. Ec is equal to 1s2. Second one, 2s2. Third one, 2p6. Then 3s2. Next, 3p6. 4s2. Next one, 3d10. 4p1. Now count. 2 plus 2, 4, 10, 12, 18, 20, 30, 31. Here we can be used, for gallium we can be used argon. Argon, the atomic number of argon is equal to 80. Okay, atomic number of argon is 80. So we can be take 2, 4, 10, 12, 18. This much is argon electronic configuration. So remaining you should be right. So Ec is equal to argon Remaining. What's the remaining? 4s2, 3d10, 4p1. This is the short way. We can, if you have any doubt, we can be discussed later. Okay? Please take down. Next about the chemical properties of boron. Chemical properties. Chemical properties of boron. The first property, boron is only a non-metal in this group, is less reactive. Boron is the one of the non-metal. Earlier I told you about the boron is a metal alloy, but it is a less reactive. However, it shows the reaction at high temperature. Many compound is an electron deficient due to the small size, high ionization energy. About the chemical properties of the boron. Here, how the reaction, chemical reaction between the boron. We are taking chromium. I think that it's a direct combination of metal with the boron. Direct combination of metal with boron. We are taking chromium. What is the formula for chromium? Cr. It's atomic number 24. Chromium metal reacts with the N molecules of boron. We get what? Chromium bromide. Metal bromide. It's the first reaction. We are using the temperature 1500. We are giving the temperature 1500. The first reaction. Next one, the reduction of boron trihalide. The reduction of boron trihalide. Okay. That is, we are taking boron trichloride. Boron trichloride. Boron trichloride on react with metal. Boron trichloride on what's the formula for boron trichloride? BCl3. With BCl3 on reacts with metal, we are taking one of the metal is simply take the W. We are taking, and the temperature is 1500 in the presence of 1500 in the presence of H2. The 1500 H2 we get it. Metal bromide, W means metal bromide with the chlorine, and also the evolution of hydrogen combines the chlorine, HCl. Then how can you balance the equation? The balance in the equation is very, very important. Simply we can take 2, then here having 6. So we can use here 2, there is a 4 over, remaining having 2. Hydrogen and the boron, that's a 2. The metal also 2. I think that the equation is balanced. And then the next one is formation of hydride. Next preparation, formation of hydride. Here's one of the very, very important one-word question. Boron does not react directly with the hydrogen. Boron does not react directly with the hydrogen. Here it forms a variety of hydride called boranes. It's a very, very important question. How is boranes prepared? Here we are taking boron trifluoride react with sodium hydride. Boron trifluoride formula. Boron BF3, boron trifluoride reacts with the sodium hydride formula NaF. Here, this sodium combines sodium hydride. Boron trifluoride reacts with the sodium hydride to form. This sodium combines with the fluorine. We get NaF. NaF plus boron hydrogen to form diboron B2H6. How can we balance the equation? Here having hydrogen 6, so you can be making 6. Here have sodium 6, sodium 6. Fluorine also having 6, so we can be making 2 here. So the equation is balanced. It's a very repeating question. Very important question. The formation of hydrogen. Please all of you take down this question. From boron trifluoride, how will you prepare diborate? Diborate, like borates. It can be say borates. B2H6. And the temperature, also you must write the temperature. It's called 450 Kelvin. 450 Kelvin. Temperature also must. For the temperature, if the question is 3 mark, 1 mark is less for the temperature. Okay, 450 Kelvin. First equation, the chemical properties of boron. First equation with the chromium metal. Second one with the boron trichloride. The third one boron trifluoride. Okay, my dear students. Today assignment you should be learn. What is today assignment means? Some of the common allotropies of P block element. That is the page number 31 in the first volume book. All of you must learn that question. It's very important. And also, if you have any doubt from this topic, please contact me. My phone number 9489340120. Please contact my phone number. I will clarify your doubt with the help of the textbook. Thank you all of you. Have a nice day.